Alrighty, so let's solve some trig problems. So here we have find the unknown length and find the unknown angle. So let's do both. Here we've got find the unknown length of this. Well, depending on what you've been given, you will solve it differently. If you were given two sides, you don't need trigonometry to solve it. You already know you can do Pythagorean theorem when you're given two sides. You do this squared plus this squared equals whatever it is. This squared plus this squared equals something. And it will equal, whatever it equals also is the equal to this squared, and then you solve, right? But here you're not given two sides to find a third. So you can't use Pythagorean theorem. You need to use trigonometry. So we need to look, we always start at the angle. So the angle is 20. So is this opposite or adjacent or hypotenuse? That's opposite, this is adjacent. So if this is opposite and we want to find the unknown length, so let's call this side B and this side C. I can't remember if we talked about this previously, so let's just go back for a second. I'm just going to write something up here. When you are given side lengths, let's say A, B, and C, whether it's a right angled triangle or not, the vertices, which is a fancy word for the corners of the triangle, will always be written with capital letters. That's the proper way of doing it. If you want to know what the letter is that goes with the side lengths are always written in small letters, and the sides have the same letter as the angle opposite them. So if this is angle A, this will be side A. If this is angle B, this will be side B. And if this is angle C, it'll be side C. Now, you know side C can also be written as AB, but if you're writing it as one letter, they're small letters, opposite, same letter as opposite the angle as written. Okay? So that's why I did this. I called this side B, and this side C, and this is side A, but it was already given. Now, if I want to find, I have to find both of these. So I'm going to find B first. So here's the process. 1, you look at the angle. 2, look at what's given. And 3, look at what you're looking for. So as promised, you start at the angle. So we look at the angle, we look at what's given, opposite, and we look at what we're looking for, which is adjacent. So what trig ratio, knowing that we spell SOHCAHTOA like this, what trig ratio uses opposite and adjacent? Opposite and adjacent is tan. So we will say tan of 20 degrees, because remember, there's no tan. It's always the sine, cos, or tan of an angle. So the tan of 20 degrees equals opposite over over adjacent. And then we solve. So this is a 6. I'm just going to curl that so it doesn't look like a B. And now I've got a proportion, so I'm going to cross multiply. So I've got B times this equals 6 times 1. And then I'm going to divide both sides by this. So I have B on its own equals 6 over tan 20 degrees. And then you punch that into your calculator, you get a number. Okay? So once you have the number, you can now do Pythagorean theorem with that number and this to find this, or you can solve with trigonometry. So let's solve with trigonometry. Here we know, let's pretend we didn't get B first. Let's say we're going to get C first. So it's the same process. You look at the angle, look at what's given, look at what you're looking for, and then you determine which ratio you're using. So I'll call this step 4 is decide using SOHCAHTOA. And then you just write it up and solve. Okay, so from the angle, what's given is opposite. What we're looking for is hypotenuse. Which trig ratio uses opposite and hypotenuse? It's sine. So we're going to say that this sine of 20 is 6 over c. And then we're going to cross multiply. And we're going to see that c times sine 20 equals 6 times 1, which is 6. Divide both sides by sine 20 is c equals 6 over sine 20. And you punch it in your calculator and you get a number. And certainly if you wanted to check, this squared plus this squared will equal this squared. Okay, that's what happens if you're looking to find an unknown length. Now let's take a look and see what happens when you're looking to find an angle. So when you're looking to find an angle, we still look at the angle, look at what's given. So what's given is opposite and adjacent. So which trig ratio is opposite and adjacent? We know that's tan. So we're going to say here that tan of theta equals opposite over adjacent. Now here, it's different than it was here because tan 20, you can plug in your calculator. Tan theta, you cannot plug into your calculator. You don't know what theta is. That's what you are looking for. So the way we use our calculator to do this is there's a button on your calculator that will make this to the -1. So it'll look like this. And when you do that, what happens is you flip-flop these two things. So it's called tan inverse of 4 over 3 equals theta. So in order to flip-flop these and get this on its own, we press this button and then we do 4 over 3 tan inverse or tan inverse 4 over 3, however you punch it into your calculator. Different calculators have different orders, and you get the number. Now, what is your calculator doing when it's doing this? What it's saying is here, you're saying the opposite over the adjacent of some angle is 4 over 3. If you put this in, we'll pluck out of the program that the calculator's programmed with, and we will get what that angle is. We're going to scan the charts and see 4 over 3 is which angle and get it and grab it and punch it and display it on the screen. That's basically what's happening here. So let's do some more problems. Here we have completely solve triangle AXYZ. So what does completely solve mean? Completely solve means find all three angles and all three sides. So what I'm going to do is I'm going to go like this. X, Y, Z, X, Y, Z, and make a little chart. And these are, of course, the three sides. These are the three angles because we know capital letters are the angles and small letters are the sides. And we're going to plug it all in and see what we can find. So this is side X, this is side Z, and this is side Y. So side X is 6, angle Z is 90, and angle X is 25. So just like when you have two sides, you don't need to use trigonometry to find the third, you can use Pythagorean theorem. When you have two angles, you don't need to use you don't need to use trigonometry. You can use the three angles, add to 180, the angle sum theorem, and solve. So let's just do that. So we know that X plus Y plus Z equals 180. And we know X is 25, and we know Z is 90. And this plus this is 115. Oops. 115. And Y equals 180 minus 115. So that is 65. Okay. And I like this chart because it kind of shows you what else you need to do and you fill it in as you go. So here is the work showing that, oh, I didn't write down AST, right? I have to write down what is going on and why I can say it. So now I need to figure out side length Y and side length Z. So let's say I'm going to figure out side length y first. I'm going to start at this angle. I could start at this angle, but this one's written here, so I'll start at that one. So I start at the angle, and I'm given this, and I'm looking for this. And this is opposite, and this is adjacent. So opposite and adjacent is tan. If you don't remember how to spell SOHCAHTOA, then just start getting in the habit of writing it at the top of every page until you remember how to spell it. So opposite over adjacent to 25 is tan. So tan 25 is equal to 6 over y. And then you'll note you've got here this. So we've got y tan 25 is equal to 6 times 1. And then we divide both sides by tan 25. So y is equal to 6 over tan 25. You punch it into your calculator, you get a number. Put it in here. And then you're going to do the same thing. You can do either Pythagorean theorem with these two, or you can do the same thing which we just did with the trig and do this and this. So let's say you were going to do that. So we've got we're given 6 and we're looking for z, and that's opposite and that's hypotenuse, and that's sine, opposite and hypotenuse. So the sine of 25 is 6 over z. Now I want to ask you something. Have you been noticing that with all these times I do this cross multiplying thing, whatever you have a proportion, you can also just swap on the cross. So when I say that, what I mean is, you see here, if we would have just swapped these, I would have had y over 1 equals 6 over tan 25, which is what I ended up with. Y over 1 equals 6 over tan 25. So you can just swap these also. I can just go right from here and say z equals 6 over sine 25 degrees. If that is like, what? I don't get that at all whatsoever, then you just keep doing this procedure until you do. I will bring it up again and again so you can hear this in the future. Okay, so we have to punch these in our calculator, and then we are going to get going to the next question. The next question, just pause for a moment before you, unless you've already put it in your calculator, that's fine. Let's look at what happens where here we were given an angle and a side. Here we were given two sides. So we're going to completely solve for ABC triangle. So ABC, ABC. There's our little chart to fill in everything so we don't have to do a final statement at the end. We know this is side A. This is side B. We don't have, oh yeah, we know this. I forgot about that one there. So what we cannot do is this, because we only are given one triangle. So think about what to do and check out the next video, and I'm going to punch this in the calculator, do this so you can check your answers.